Right guys, let's have a go at this one then, number 16. Y equals log 3x times sec x. We better put down our table of standard derivatives, hadn't we? So we've got y dy dx, because we haven't written down sec x before. So, we've got constant goes to 0, x goes to 1, x to the n, say, goes to n x to the n minus 1. We'll go down the list, and on the list somewhere will be sec x, and that differentiates to sec x tan x. That's how you write it. That's what it differentiates to, simple as. Okay, we'll come back to that. It's a function of a function. This is 1 over cos, so you can actually obtain this just by differentiating using the function of function rule of 1 over cos, and you'll find that it goes to that when rearranged. 1 over cos times sine, so it ends up being sine over cos squared. But that's just a side note really, because we just need to use it from the table, don't we? So we've got product, so let's just label the product then. Let's draw our grid. And we've got u, we've got v. U is log n 3x, v equals sec x, there we go, let's put that down. So du dx then. Log, that's a function of a function, but we can do the dv dx. Sec goes to sec tan, so sec x times tan x, there we are. Now this is a subproblem, so I'm going to draw a line across a page. Whoops a daisy, just bring that back, sorry about that. I'm going to draw a line across the page if I can properly, and write subproblem. Alright, so I'll pause it and go on to the next page, and I'll do the subproblem, and then we'll come back to this part here. Okie dokie. Okay, I've just written the subproblem, so we can go back to that. We'll flick over to that page in just a moment. So I'll draw another line across the page now to say that's the end of the subproblem. Okay, and I can put the answer down here. So I'm going to put the answer down first, then we'll go and have a little look at the subproblem. This thing, log of something differentiates to 1 over the something, multiplied by the something differentiates, so it's 3. So the answer there is 1 over x. So the final answer here would be dy dx equals u dv dx, which is horrible looking, log n 3x sec x tan x, yeah, plus v du dx, and we've got 1 over x, the 3's cancel, and that'd be 1 over x sec x. I'll write the 1 over x first. And that's it. There's our final answer. Now let's just go back to look at this subproblem. So there's a slightly interesting observation I think we could make there. Let's have a look here. Log 3x then, log of something. We use the function of a function rule. Dy dx is dy du times du dx. Yeah. I'll try and move that down if I can to there. That's it. Dy dx is dy du dx. There we are. That's a function of function rule. It's log of something, so we can use the function of a function rule. So if we try that, then it's just trial and error. So the something is 3x. Let u equal 3x. Then y will equal, the u goes in here, and so y is log u. We need du dx, so that differentiates to 3. Dy du, we just differentiate log, but with respect to the symbol u. So log goes to 1 over, and the symbol is u, so it's 1 over u. Then the answer, dy du dx, dy du dx, these two multiply together. So it's 3 times 1 over u is 3x, so we put it in at the end, 3 times 1 over 3x. The 3's cancel, we get 1 over x. Now what is vaguely interesting here is the fact that, hang on a minute you might say, because that can't be right, because log x differentiates on our table to 1 over x. And now you've just told me, how can it be that log 3x differentiates to 1 over x? It can't be right. Why is that then? Well, if you think back to the properties of logs, right, that can be written times you add, so you've got log 3 plus log x, yeah, and you expand that. Yeah? So, when you differentiate this line here, what is log 3? If you type it in your calculator, what do you get? You get a number. Any number is a constant which differentiates to 0. So that would go to 0, and that's why we get the derivative of log x being the same as log 3x, because the simple property of logs is that's the result, and so that's why this goes to 1 over x, and this goes to 1 over x, yeah? That's why algebraically speaking it goes to 1 over x, because we can expand it to demonstrate that it does, because that's a constant. Alright then? That's the property of the logs there. Just a little side note, I thought it might be worth a brief mention. So let's go back to our original problem now, which I think we've done. I'm not going to bother tidying that up because I don't think we could take a sec x out of a bracket, But to be honest, it looks fairly horrendous anyway, so just leave it as is, really. And that's dy dx for question 16 then. So it's log 3x sec x tan x plus 1 over x sec x. Let's go on to the next one. Great.